This is SpaceTime, Series 25, Episode 85, for broadcast on the 1st of August 2022. Coming up on SpaceTime, has the James Webb Space Telescope already found the earliest galaxies in the universe? A new telescope for Australia to see gravitational wave sources. And while Russia's pulled out, planning continues on the Lunar Gateway Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, it's only been operational for a couple of weeks, but astronomers are already speculating that NASA's new James Webb Space Telescope may have already discovered the most distant and hence earliest galaxies in the universe. A report on the pre-press physics website archive.org claims that one of the very first images captured by James Webb shows a galaxy catalogued as Galaxies C13, which dates back some 13.5 billion years. That's just 300 million years after the Big Bang, and about 100 million years earlier than any previously identified. Galaxies C13 was detected in early release data from the James Webb's NIRCam main infrared imager. The study's lead author, Rohan Naidu from the Harvard Center for Astrophysics, says it's potentially the most distant starlight ever seen. And he says early peer review results appear to have reached similar conclusions. If confirmed, it would mean James Webb has already achieved one of its primary goals, that is finding the universe's earliest galaxies, and it's done that within its first few weeks of operations. As the authors sifted through the early James Webb Deep Field image data, they came across two galaxies, Galaxies C13 and another one not quite as ancient, Galaxies C11, that appeared to stand out. Although the light from these two very early galaxies would have been emitted in primarily ultraviolet and visible wavelengths, these would have been stretched out into broader infrared wavelengths, that is redshifted, by the physical expansion of space-time. Galaxies C13 simply appeared as a blob of red with some white at its centre in the wide deep field image. It has about 1 billion times the mass of the Sun, amazingly large considering how early this is in cosmic history. And that's raising questions about how it could get that big that quickly. Launched back in December aboard an Ariane 5 rocket from the European Space Agency's Kourou Space Centre in French Guiana, the $10 billion James Webb Space Telescope is in a halo orbit at Lagrangian L2 position, some 1.6 million kilometres away from the Earth on the planet's night side. The observatory is designed to study the first stars and galaxies, and to analyse the atmosphere of distant worlds orbiting alien stars, searching for the chemical signatures of life. This is SpaceTime. Still to come, new telescopes to see gravitational wave sources, and planning continues on NASA's Lunar Gateway Space Station. All that and more still to come on SpaceTime. Australia is about to get a new telescope array, one specifically designed to find the sources of gravitational waves generated by events such as the collision of neutron stars. The first ever gravitational wave detections back in September 2015 involved the collision of a pair of stellar mass black holes, and it opened up a new era of astronomy. The mass of the two merging black holes caused ripples in the very fabric of space-time, and these were picked up by the two LIGO laser interferometry gravitational wave observatories in Washington State and Louisiana. And while there have been dozens of detections since then, one of the big problems with gravitational wave astronomy has been getting electromagnetic spectrum telescopes pointing at the location of the gravitational wave source quickly enough. Now, with merging black holes, or even black holes consuming neutron star companions, there might not be much to see anyway. After all, they involve black holes, and so light doesn't escape. But colliding neutron stars, which could also be detected by the gravitational wave signatures, are a different story. They're visible, and their collisions are spectacular. That is, if you can get telescopes pointing at them quickly enough. And that's where the new Gravitational Wave Optical Transient Observer, or GOTO, comes in. GOTO will comprise two identical arrays of telescopes on opposite sides of the planet that are specifically dedicated to tracking down gravitational wave sources. The project, led by the University of Warwick and Monash University, will scour the skies, searching for the optical clues about violent cosmic events that create ripples in the very fabric of space-time. After setting up an initial prototype system at the La Palma Observatory on Spain's Canary Islands, a fully operational second-generation GOTO observatory was constructed. 2 telescope mount systems, with each array made up of 8 individual 40-centimetre telescopes, are now operational in La Palma. Combined, these 16 telescopes cover a very large field of view with some 800 million pixels across their digital sensors, enabling the array to sweep the visible sky every few nights. These are robotic systems that will operate autonomously, patrolling the sky continuously, but also focusing on particular events or regions of sky in response to alerts of particular gravitational wave events. Now, work is beginning on a second parallel optical array at the Siding Spring Observatory in far western New South Wales. Associate Professor Duncan Galloway from Monash University says the new site means a massive improvement in the chances of observing some visible counterpart of a gravitational wave detection. Detecting optical counterparts promptly is a key factor in how much science can learn from gravitational wave observations of events like neutron star collisions. But because gravitational wave detectors don't have the accuracy to pinpoint exactly where the gravitational waves are coming from, it took conventional electromagnetic telescopes 11 hours to detect the optical signature from the first neutron star merger event, catalogued as GW170817. And that's where the GO2 network will come in. It'll be on sky and autonomously observing the field within minutes. GOTO will provide the targeting data needed for bigger telescopes to point in the right direction in order to gather the science. Galloway says the Siding Spring Observatory will have the same 2-mount 16 telescope array as La Palma, operational in time for the start of the next observing run of the LIGO-Virgo gravitational wave detectors, slated for 2023.
The main idea is that it's built to follow up these gravitational wave events. Back in 2015, we had the first detection of a pair of black holes merging with a new kind of detector that detects gravitational waves rather than electromagnetic waves, which is what most astronomy has been based on up to that date. When we detect these gravitational waves, we only know very approximately where on the sky they come from. So the idea of GOTO is that if the gravitational wave events also have an optical, visible light signature, we can find those signatures as well and then identify much more precisely where on the sky those events are occurring.
That way you can confirm exactly what it is that's making the events instead of hoping to identify it just by the chirp.
Exactly. If all we have is the chirp, the gravitational wave signal, we can't determine exactly where it is on the sky, which means we can't determine exactly how far away it is, the host galaxy, and there's, of course, lots of things we can get additionally from the visible light that we see from those kind of events, potentially.
Yeah, and with black holes, there's another problem in that they don't normally emit light anyway. So if a supernova, say, occurs, a core collapse supernova, and it collapses down to form a black hole, there may not be a visible signature of it, but the chirp will be there. And so in this way, you'll be able to confirm that because there's nothing there, it definitely was a black hole that was formed.
That's true. And LIGO's seen mostly black hole mergers while it's been operating. We've actually followed up some of those events with the GOTO prototype that's on La Palma. And you're right, no confirmed detections have been made in optical or any other band for those events. But there's another kind of event, which is the mergers of neutron stars.
Oh, that's
these
very
neutron stars,
exciting, yeah.
what's left over after the end of the evolutionary history for a medium-sized star. And if you get them in a pair, eventually they'll merge and cause a big burst of gravitational waves, just like a pair of black holes. But they'll also produce a big flash of gamma rays, visible light, X-rays, radio waves, pretty much everything. And we know this because we've actually seen one of these events, and that happened back in 2017. There's a very famous event called GW170817, and that's the kind of event that GOTO is designed to pick up.
You'll have telescopes on opposite sides of the planet, and the time to actually slew these telescopes to look at the target area will be greatly reduced.
Yeah, there's a bunch of factors. You need coverage over the entire Earth, basically, because you don't know what time these events are going to occur. So you want it to be happening at night somewhere where you have a telescope. But it's also about one of the design features of GOTO is a very wide field of view, what we call the field of view, which is just the area on the sky that the telescope can observe simultaneously. So because the uncertainty regions that LIGO produces, because those are so large, because the localization ability is so poor, we need to very quickly cover a very large region of the sky to try and find the counterpart. And so we do that with GOTO by assembling arrays of telescopes. Each individual telescope is about 40 centimetre in diameter. And on each mount, we have 8 of them. And per site, we have 2 mounts. We have 16 telescopes altogether. And they're basically tiling the sky to kind of produce a composite telescope with an enormous field of view. And that's enough to cover one of these big LIGO error regions with just a few exposures.
Preparing a site at Siding Spring. Tell me about it.
Yeah, so it's a very well-known site for Australian observers, the Siding Spring Observatory, where our largest optical telescopes already are. We've got the 4.3 metre Anglo-Australia telescope and the 2.3 metre telescope. There's SkyMapper. It's really our premier Australian observing site by nature of the elevation. It's about 1,100 metres on top of the Warrumbungles there in the Coonabarabra, but also the infrastructure and the expertise of the technical staff that are there available. And that's run by the Research School of Astronomy and Astrophysics out of ANU.
You mentioned them earlier, the excitement of not just having a couple of black holes merged together, but also neutron stars and neutron stars and black holes. So we've got these 2 other types of events.
Yeah, so there's a couple of options, like you say, and to us optical observers, the black holes are a bit boring because they're completely black. They don't produce any other kind of emission that we can use. But if we can get a neutron star there in the system, then we potentially have some other kinds of emission that we can work with. And the neutron star collisions are interesting. And, we've had predictions of what to expect, and we've had those really fantastically verified with the 2017 event. And that was the way the astronomical community responded to that. It was like Christmas. I mean, we had 70 observatories that were following up that event. I think it's the most observed astronomical event in history, and we learned an awful lot about what these events do and the physics behind it, what kind of things they produce.
Yeah, confirmed where gold came from finally.
yeah. But there's black hole neutron star systems. We think we saw one with LIGO in terms of the gravitational waves, and we can determine that because we can get an estimate on the masses of the objects that were involved in the collision, but we didn't see any counterpart of that. And the big hope is that when LIGO comes back online, we'll see more of these events being detected with gravitational waves, and we'll have additional chances to detect the possible counterpart in visible light and everything else.
I guess the lack of detection with the merger of a neutron star with a black hole would be the fact that the black hole would have swallowed it up.
Well, but what it does before it swallows it up is it tidally disrupts it. So, So I understand that you can get some of the material from the neutron star will get thrown off in that encounter, and so that gets heated, obviously, and neutron stars are very neutron-rich, so you get a lot of interesting nuclear reactions that produce lanthanides and other things like gold, and we can potentially detect the radiation that comes from those events. But of course, the other problem is it could have been too far away and hence too faint, and also it could have been that we didn't get to it fast enough and it was there somewhere in the field and we just missed it because, we just didn't have the right observational capabilities on sky at the time.
That's Professor Duncan Galloway from Monash University. And this is SpaceTime. Still to come. Planning continues on the Lunar Gateway Space Station. And later in the science report, a new study warns that napping is associated with higher risks of high blood pressure and stroke. All that and more still to come on SpaceTime. Japan has confirmed its participation in NASA's proposed new Lunar Gateway Space Station project. Gateway will act as a staging post and jumping-off point for missions to the lunar surface. Spacecraft from Earth carrying people and supplies will dock at Gateway, where they'll then transfer to lunar descent craft, which will shuttle them down to the lunar surface. Right now, the first two modules of the Lunar Gateway Space Station are targeted for launch together no earlier than November 2024. That'll be on a Falcon Heavy rocket from Launch Complex 39A at the Kennedy Space Center. The current plans will call for the Japan Aerospace Exploration Agency JAXA to supply Gateway's International Habitation Module IHAB with environmental controls and life support systems, as well as batteries, thermal controls, and imagery components. That'll all be integrated into the ESA-built module prior to launch. As well as IHAB, ESA will also supply Gateway with a spacecraft refueling module and the enhanced communication relay facilities which will link astronauts and equipment on the Moon's surface with mission managers back on Earth. NASA are supplying two modules. There's the Gateway's Power and Propulsion Element, or PPE, which will provide power, attitude control, and orbital transfer capabilities to the space station, as well as the Core Habitation and Logistics Outpost, or HALO module, where astronauts will live and conduct their research while visiting Gateway. The pressurized living quarters will provide command and control systems for the lunar outpost, as well as power distribution for the other modules and docking ports for visiting spacecraft such as NASA's Orion, lunar landers, and logistics supply craft. The HALO module will also host scientific investigations by way of both internal and external payload accommodations, and it will provide the main communications hub with lunar surface expeditions. And the Canadian Space Agency will provide Gateway's robotic arm, as well as robotic interfaces for Gateway modules, which will enable payload installation. Now, originally, Russia were also to be part of the project, but they've pulled out of Gateway following the imposition of sanctions against Moscow over its invasion of Ukraine. Russia is now planning to join China in building a joint base on the Moon, which is planned to be operational by 2026. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that napping on a regular basis has been associated with higher risks of high blood pressure and stroke. The findings, reported in the American Heart Association journal Hypertension, is based on data from the UK Biobank, a large biomedical database and research resource containing genetic, lifestyle and health information on 500,000 UK participants between the ages of 40 and 69 who lived in the United Kingdom between 2006 and 2010. The study found that people who usually take naps had a 12% higher likelihood of developing high blood pressure and a 24% higher likelihood of having a stroke. Researchers also found that people younger than the age of 60 who usually napped had a 20% higher likelihood of developing high blood pressure compared to people of the same age who never napped. After the age of 60, regular napping was associated with a 10% higher risk of high blood pressure compared with those who reported never napping. The results showed that if napping frequency increased by one category, that is, from never to sometimes or sometimes to usually, high blood pressure increased by 40%. Put simply, higher napping frequency was directly related to the genetic propensity for higher blood pressure risk. Now, this may be because while taking a nap itself isn't harmful, many people who take naps do so because of poor sleep at night. And poor sleep at night is associated with poorer health, and taking lots of naps simply isn't enough to make up for that. New research out of the United States suggests that, contrary to popular recommendations, taking vitamin D supplements did not lower one's risk of breaking bones, especially among healthy midlife and older people. The findings, reported in the New England Journal of Medicine, are based on a study in which either vitamin D supplements or a placebo was administered to a group of 26,000 participants aged 50 and over. They were checked after 5 years, and they showed no substantial differences in the likelihood of bone fracture between the two groups. Most cat species are solitary and territorial, but domestic cats often live in big groups. So how do they put up with each other? Well, Japanese scientists wanted to find out, so they devised an investigation to study 3 groups of 5 cats living together in a shelter. They filmed the cats' behaviour, measured their hormonal levels, and checked out the composition of their biome, that is, the bacterial flora in their intestines. Analysing the data, they found that cats with lower levels of the hormones testosterone and cortisol were more sociable, sharing their space and living together. And cats who hung out together wound up having similar gut microbiomes to each other, with a link also found between gut microbiomes, social behaviour and cortisol levels. The findings, reported in the journal PLOS ONE, also showed that cats with high levels of oxytocin, often called the cuddle chemical, were less sociable and more lonely than others, suggesting that oxytocin might have a different function in normally solitary animals than in social ones such as humans. Well, time once again for the silliest story of the week. And today the award's got to go to the old spoon bender himself, Uri Geller, who is now warning us of an alien invasion, not from the Mexican border, but from outer space. Geller claims the human race is already being monitored by extraterrestrials, and they're preparing to make contact, which he says will happen sometime within the next 5 years or so. Tim Mendham from Australian Skeptics says Skeptics will take great pleasure in reminding him of his prediction in 5 years from now.
You can always tell when Yuri's got a new book coming out, or if he's suffering from fame deprivation, that he makes another statement. He's made a few lately about he's going to find the Holy Grail. I think it's just about round the corner. It's just going to happen. Or this one that he made fairly... funny enough, no. He says that he's using, and this is a quote, remote viewing to send his mind through space and time to have a look at the aliens in action, or that might be in action. I'm not quite sure. Apparently they'll be here soon, and they'll be invading, so you have to be prepared for this. They've obviously been monitoring us for a long time. He's obviously suffering notoriety deprivation or something that no one's noticing him anymore. He keeps popping up, still running on the spoon bending.
The old spoon bender.
Yeah, but that was like 50 years ago. So, I mean, but he's still running on it. No one can figure out why you want to bend spoons, but never mind. The reason you want to bend spoons is they're easy to bend. But I mean, yeah, that was been seriously debunked, but he's still running on it. I don't know if people treat him as a interesting eccentric. He comes up with all sorts of claims. As I said, the Holy Grail, now the aliens. A while ago, he reckoned he helped Scotland or England or whatever advance in the World Cup where he moved the earth when someone was taking a penalty kick and therefore they missed. He'll take advantage of everything. He'll hop onto a story and coattail it around to show that he was involved.
Yeah, he was claiming Brexit was his...
Well, he was claiming a number of things, actually. He was claiming he was going to make Theresa May Prime Minister, which I think he made the claim after she became Prime Minister, I don't know, which might have been a double-edged sword for her. And he was going to stop Brexit, which didn't work. And these things, the claims he makes and then conveniently forget, although the skeptics never forget. We're difficult people. We keep track of these comments and go back to them. But you said so-and-so. But, yeah, we'll pass it off.
Tickle the sickle to stop World War III?
Yes, that's right. He sort of,
Is this something you need to do personally with Vladimir Putin?
Yeah, well, he often drags these things out to get people's involvement. Even back in the old days, he'd be on TV and say, pull out your watch, rub your watch, it'll start again, all that sort of thing. And people send me the details, and people would send him details. Oh, that's amazing. And then, of course, after 12 hours, the watch stopped because it just hadn't been shaken for a while. But, yeah, this is one where he calls it tickle a sickle, and this is designed to stop World War III, and you have to rub the Russian hammer and sickle symbol at 11 a.m., 1:11 p.m., and 11:11 p.m. So that's 3 times in the one day, and that will force Vlad to step back from the brink of all-out warfare. I don't think it's worked so far, although perhaps we'll never know. And, of course, if Putin does not declare out-and-out war on the rest of the world, Yuri will claim that, of course, as a success, as he does. He ignores the failures and claims the successes very readily, actually, even if they're not anything to do with him. But he's often used people out there, whether through a newspaper, whether on TV or whatever, to become involved. And, let's all think together and we'll change this particular thing. Tickling a sickle and sending a telepathic message to Putin.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.